All right, welcome to the second part of lesson 6.1. Hopefully I can do this one in under 30 minutes. I apologize, but like I said, these are pretty heavy sections here. So we're continuing along with properties of square roots, and this time I want you to evaluate square roots. So we're going to use some substitution here just to make sure you're very savvy with especially this expression, b squared minus 4ac. Maybe you noticed a portion of that on the quadratic formula poster in the classroom. You'll hear it in my quadratic formula song on my website. So you're going to need to know how to use this and how to plug in values and just be savvy about that. So that's our step one today, being able to evaluate expressions that are underneath a radical sign. So your step one, just plug it all in. So b squared. Remember, if I tell you that b is a negative amount, that it makes a big difference if you don't put parentheses around it when you plug it in. If I want b to be -8, that means I need to keep the negative with the 8. Don't forget the parentheses or your answer will come out wrong. You could just always be in the habit of putting them in parentheses when you plug them in. The time it makes a difference is when there's an exponent. So b squared would be the quantity of -8 squared minus, I want to take 4 times a is 2 and c is 4. The good news is I have no problem with you grabbing your calculator right now and typing in the quantity of -8 squared minus 4 times 2 times 4. You can't just type in the square root of all that though, because it's going to give you a decimal, and I don't want decimals, I want perfect answers that are exact. So keep that square root sign. If you have your calculator handy, type it in. If not, press pause and grab it. Type in the quantity of -8 squared minus 4 times 2 times 4. You should get 32. So if you think back to yesterday, we don't know if this is simplest form or not, and when you evaluate it needs to be in simplest form. So we need to break down this 32, right? Now I know there are several ways that I could break down 32. I could say 8 times 4, right, is 32. And a better way, I think, would be to take 16 times 2. If you did 8 times 4, that's fine, but you're going to have to keep breaking it down. If you do 16 times 2, I know the square root of 16 is 4 and 2's prime, so I have my final answer, 4 square root of 2. All right, we're going to try one more like that. So again, I'm going to write my radical sign. I'm going to put the b in parentheses, because when b is negative and you're squaring it, it makes a big difference. I'm going to say that over and over again. I want to subtract 4 times a is 2 and c is -5. I didn't wrap that one up in parentheses because it doesn't have an exponent attached to it, so it's not going to make a difference in my answer. If you wanted to put parentheses around it, have at it. It won't matter. All right. Now, in your calculator, you can type in the quantity of -6 squared minus 4 times 2 times -5, and it's going to give you 76. So we get the square root of 76. I'm not sure if that's actually in simplest form or not. So I know that 76 is even, and that 2 will go into it, right? So if you take 76 and you divide it by 2, you'll get 38. I know 2 goes into 38 also, right? So if 2 goes into 76 and 2 goes into 38, doesn't that mean there's 2 2's? So let's try taking 76 divided by 4. Ooh, that works. You can take 4 times 76 divided by 4 is 19, which is prime. That's a much quicker way to get there. The square root of 4 is 2, and I'm left with the square root of 19 left inside. So now that's in simplest form. Awesome. All right, now we want to take a look at simplifying radical expressions, but there's a little bit more to these expressions than the ones you did before. So here I have 6 plus the square root of 8 divided by 2. It's not multiplication on this one. This one's a little bit tougher. Okay, we know that expressions are in simplest form when there's not a radical in the denominator and there's not a fraction underneath the radical sign, and the factors of the underneath the radical don't have any perfect squares. So this one, it does have some perfect squares in there. So I'm going to rewrite this, and I'm going to rewrite 8 as 4 times 2. And now I have some business to take care of in here. So I know that the square root of 4 is 2, so now I'm left with 6 plus 2. This 2 doesn't get to break out over 2. And I'm hoping that you're saying, hey, there's a bunch of things I can simplify here. This right here, these are two separate terms, both of which are being divided by 2. So I'm going to simplify this. I'm going to simplify this term, 6 divided by 2. That's 3, right? And then 2 divided by 2 is 1. I don't need to write that 1, but I'm left with the square root of 2. So simplest form would be that. If this isn't making sense to you, I need you to understand that this right here, 6 plus 2 times the square root of 2 divided by 2, means the same thing as 6 divided by 2 plus 2 times the square root of 2 divided by 2. That might make more sense to you, and if you needed to break it apart and write it like that, be my guest. I just have Beauty and the Beast now in my head. Be my guest. All right, I'll save the songs for class, sorry. 6 divided by 2 is 3, and then here those would equal 1 when you divide them, and you're left with that square root of 2. So hopefully that helps. All right, take a look at the next one. I have 18 plus the square root of 72 divided by 6. Okay, so maybe you're thinking, can you simplify this right off the bat? That wouldn't hurt. I mean, you could do that. I'm going to do the problem the same way I did the other one, but you could start off rewriting it as two separate problems if you so desire, if you're having a hard time with this. Okay, so this 72, I need to break that one up. 18 plus, for 72, let's see here. I know that if I take 72 divided by 2, I get 36, right? Yeah, so I could do that. But if I take 72 divided by 4, I get 18, so I could do that. I wonder if I could take 72 divided by 6. 72 divided by 6, that gives me 12. I can keep going. There's all different kinds of ways to break it up. Do you know what 72 divided by 36 is? It's 2. So I want to jump to the largest perfect square factor that it has. So 36 times 2 is 72. Again, if you wanted to take the long way around and start off and continue to break this down off the bat, let's say you didn't choose 36 and 2. Let's say that you chose, I don't know, 9 times 8. If you chose 9 times 8, then you could pull that square root of 9 out and then break the 8 down into 4 times 2 and then pull the 2 out, and you'll end up getting the same answer. All right, to make a short story long, geez, Mrs. Trombley, sorry. Let's pull out this 36, so I'm left with 18 plus the square root of 36 is 6. Square root of 2 is left inside, I'm left with this 6. Now, remember, this means the same thing as 18 over 6 plus 6 times the square root of 2 over 6. You can break it down that way. There's an addition sign between. That means each term is being divided by 6. Well, 18 divided by 6 is 3. 6 divided by 6 is 1. So, again, I'm left with 3 plus the square root of 2. The moral of the lesson is that all the answers are the same. Sorry, they just came out that way. All right, turn it over. We have a couple more to do. I'm only at 8 minutes. I'll wrap it up. Make it like a present. Wrap it up. All right, I have 1 minus the square root of 27 over 4. Maybe you want to pause and try these next two by yourselves and see if you can get the correct answer. That would be a great way to go. Okay, I'm going to break it down. Let's break down this 27. I know that 9 times 3 is 27, and I'm happy about that because 9 is a perfect square and 3 is prime. So when I pull out that 9, it's going to pull out as a 3. Square root of 9 is 3. And I still have a 3 left inside. And there's my 4. Okay, now, can I simplify? Is there a number that goes into 1 and 4 or 3 and 4 to simplify this even further? There's not. So with this one, so happy, that one's done. Again, I didn't need to simplify these fractions here because 1 and 4 don't have any other common factors besides 1. Same with 3 and 4. So that's why we're done. All right, last one like this, then it'll be a story time. I have to give you a math story so that when you see them in your homework assignment, you don't freak out and see the words and Okay, 8 plus, 32. What are you thinking for 32? I know you're probably thinking 8 times 4, but wouldn't 16 times 2 be even better? Because 16 is the largest perfect square that divides into 32. So, oops, I gotta write that 2 there. So I really have the 8 plus the square root of 16 is 4, and I'm left with 2, and this is over 2. Now I'm seeing the 8 and the 2 and the 4 and the 2, so I'm going to break this up. 8 over 2 plus 4 times the square root of 2 over 2. Remember, there's an addition sign that means each term is being divided by 2. That's how terms are separated, by addition or subtraction signs. 8 divided by 2, that's 4. 4 divided by 2 is 2. So this one's not the same answer as all the rest. The answer would be 4 plus 2 times the square root of 2. All right, last but not least, I was so excited when I found that cute little clip art to go along with our story. Once upon a time, this couple lived in a mansion, and the man that lived there was an artist, so he decided he was going to make an art room. The circumference, C, of the art room in a mansion is given by this beautiful little formula here. Find the circumference of the room. So this doesn't tell you the circumference, this is just the formula. Find the circumference of the room if in that formula A equals 20 feet and B equals 16 feet. So remember at the beginning of this where we had to evaluate square roots? That's really all this problem is about. And good news with this, you know how I don't want decimal answers, I want lovely exact answers? That means you're going to leave pi as pi. When you're working with this, leave pi as pi. Don't plug in 3.14. Leave it alone. Okay, so our goal is to find the circumference. And the circumference we know equals 2 times pi. And we have the square root of. Okay. It says that if A is 20, so I'm going to plug in 20 for the A, and B is 16. Do you see how I didn't put parentheses around those even though I'm squaring them? It's because they're not negative, so it doesn't really matter. And I'm supposed to divide that by 2. All right, our next step, when you see that you have problems within the fractions, you need to take care of the numerator, then take care of the denominator. So I have no problem if you take 20 squared plus 16 squared, hit enter, and then divide that by 2. So if you do that, maybe you're typing it in now, 20 squared plus 16 divided by 2, hit enter. Or sorry, 20 squared plus 16 squared. Enter, then divide by 2. You should get 328. Okay, so this, I'm guessing that there are some perfect squares located in there somewhere. That would be my guess. What do you think? Okay, so let's keep going here. You see 328, right? So if you go through your list of perfect squares here, the first one I would try is a 4. So if you take 328 and you divide it by 4, it comes out to 82. So we can write that. We can write 82 times 4. And I know this 4 is going to be able to come out. For 82, let's keep going. So I know my 4 is good. I'm going to just kind of keep it in there for now. For 82, if you divide 82 by 2, you end up getting 41. So you would have 41 times 2 times 4. Okay, I know the 4 can come out. 2 is prime, right? Isn't 41 also prime? So that means that these stay. The square root of 4 is the only one that gets to come out. So let's let the square root of 4 come out. When it comes out, it's going to come out as a 2. So I have to take 2 pi times 2, and I'm left with 41 times 2 in here, which is 82. Out here, this is where my associative property comes into play. I can group these as, or commutative actually, because I'm moving around. 2 times 2 is 4, and 4 times pi is 4 pi times the square root of 82. And this is in feet. And this is actually my answer. It's a perfect, exact, lovely answer. That's what you want it to say. I don't want any decimals. All right, you're done. Finally, in under 15 minutes. It's a record. See ya.